Welcome to the AP Chem 2022 FRQ video series. Today we'll be solving question 4 of the 2022 AP Chem free response questions released by the College Board. Whenever a question pops up on the screen, please pause the video and read it to yourself. Okay, so part A might initially look confusing with this grams over liters concentration, but if you notice that it says present in 1 liter of solution, this is per liter, so you don't even really have to worry about the 1 liter thing at all, and you can just look at this as being given grams of NH2Cl, and you're given a molar mass, and all they want is the number of moles, so this really turns into some very simple stoichiometry. Use the molar mass to convert from grams to moles to get your final answer. So part B talks about the intermolecular forces and says that NH2Cl is highly soluble, whereas NCl3 is nearly insoluble. And it also says to talk about interactions between solutes and water. So what this means is that the phrases that you need to be using in your answer are solute-solute interactions, and solute-solvent interactions. So this is what we need to be talking about in our answer. Both of these need to be used. We need to be comparing the solute-solvent interactions, especially between these two. And that's just saying that NH2Cl is able to do something with water that NCl3 is not able to do, and we know that because of the solubility differences. So we should be able to start out this problem by just listing out the intermolecular forces that occur in both of these molecules. So all molecules are going to have LDFs, the London dispersion forces. So just list that out. We're going to start with NH2Cl. So has LDFs. Now, is there anything else that this could possibly have? Well, this is when we turn to the Lewis structures, and here I see that H is bonded to N, so this tells me that it has hydrogen bonding capabilities. That is dipole-dipole also implied there as well. So has dipole-dipole and hydrogen bonding. So to be specific here, say hydrogen bonding. And then now you need to list the intermolecular forces of the other one because you're comparing. So obviously has to have LDFs. And we do not see any capability of hydrogen bonding here. And also it says that it is nearly insoluble, so that should be like giving you a hint that this is nonpolar. NCl3 is a nonpolar molecule, so only LDFs makes sense. Has LDFs as intermolecular forces. You can use IMFs to abbreviate. So now let's look at the LDFs. Okay, so both of these molecules are of comparable size. We can see the similar elements in both of them, so we will say that. The LDFs are not what are causing this difference in solubility. It's something else, and that something else is going to be the capability of NH2Cl to hydrogen bond. That's going to be the difference that we're seeing. So now we got to say that. Now we're going to talk about our solute-solvent interactions, okay? So this increases the strength of solute-solvent interactions with water. And since we know it's soluble, we know that these solute-solvent interactions are overpowering solute-solute interactions because that's just the concept of solubility. So you need to say that. And then since water is a polar molecule. It is a polar molecule that can hydrogen bond. And then, of course, now we have to link it back to NCl3. If we don't do that, then it's not going to be a complete answer. So NCl3 does not have this increased strength of solute-solvent interactions. Like, it does not behave the same way with water. That's what we're saying here. Since it cannot hydrogen bond. So for part C, I am given a starter amount and I'm given a molar mass. So the strategy that I would take first is just go with stoichiometry and see how it is from there. So I have these grams of NCl3, and my intuitive strategy would be to convert this to moles and then see what happens and see if that can help me get to my amount of energy. That can help me get to my kilojoules. So this is over 1 mole NCl3. And now we have moles of NCl3. And then we have this number that we haven't used yet. And the units here are kilojoules per mole. We have moles up here. We want kilojoules. So just by dimensional analysis, what we're going to do is do 1 mole of NCl3. And for every 1 mole of that, you require 32.9 kilojoules to vaporize it. Now the moles to moles will cancel out, delivering the final answer of 4.10 kilojoules. That's all for this video. Thank you for watching and good luck studying.